Hello students, today we will discuss R-S configuration. So this is very important for IIT-JEE NEET and EAMCET aspirants. So in this R-S configuration, so first of all we will discuss the basic fundamentals topics in R-S configuration. After that we will discuss some examples based on R-S configuration. Here R means rectus, means the plane polarized light rotation towards clockwise direction or right hand side rotation. S means sinister, the rotation of a plane polarized light towards left hand side or anti-clockwise direction. That is very important. Okay, if the plane polarized light rotates towards right side or clockwise, it is R direction. If the plane polarized light rotates towards left hand side or anti-clockwise direction, that is S configuration. Okay, so what is chiral? So chiral means when a tetrahedral atom has four different substances, we can say it is a chiral molecule. So means the tetrahedral atom has four different substances like A, B, C, D or 1, 2, 3, 4 like this. So means all the four atoms or groups are different, then we can say it is a chiral compound. If the center atom is carbon, then it is a chiral carbon. We can say chiral carbon. If the centered carbon atom has two different atoms or groups and the remaining two atoms are same, then therefore it is not a chiral molecule, it is a achiral molecule. Okay, so here we have property in R-S configuration or optical isomerism, that is chirality is very important. It is the property of optical isomerism. The isomers which are non-superimposable on their mirror images. For example, pair of hands. So here right hand and left hand. So these are pair of mirror images, but these are not superimposable. So the non-superimposable mirror images we can say optical isomerism, and these isomers we can say chiral, and the property is known as chirality. Okay, so the isomers which are non-superimposable on their mirror images are said to be chiral, and the property is known as chirality. Okay, right. So here you can see this is the chiral carbon atom, has four different atoms or groups A, B, C, D. Okay, so here some principle, that is this is the light source, this is normal light. So the normal, if the normal light is traveling to the sample, it rotates atoms or groups in all the directions. So that's why it is not possible to find out R-S configuration is very difficult. So therefore this normal light is passing through the nickel prism or polarizer, it converts into plane polarized light. So this plane polarized light is passing through the sample containing chiral compound. Okay, so the sample should be contain chiral compound. Okay, so this chiral compound is absorb plane polarized light. So this chiral molecule can rotate the plane polarized light towards the right hand side or towards left hand side. If the rotate the light towards right hand side, that is R configuration. If rotates towards left hand side or anti-clockwise direction, that is S configuration. So this is the direction of light propagation. So this is fundamental principles in R-S configuration. see the examples of R-S configuration. So this is lactic acid, So this is a chiral carbon atom. So this chiral carbon atom is attached with so different functional groups OH, COOH, CH3, hydrogen. So we will give the priorities based on their atomic number. So the concept was given by Kahn, Ingold, Prelov. So we are giving the priority based on their CIP rules. So according to these CIP rules, give the priority 1, 2, 3, 4 order. The first priority of more atomic number and the least priority with less atomic number. So here this chiral carbon attached with oxygen atom, the atomic number of oxygen atom is 8. So therefore here we will give the priority number 1. Here we have 2 carbon atoms. These chiral center attached with 2 carbon atoms COOH and CH3. The atomic numbers are same. So if the atomic numbers are same, then go for the second atom. If the second atom atomic numbers are same, so then go for the third atom. So here the second atom is oxygen and here the second atom is hydrogen. So therefore oxygen atomic number is higher than the hydrogen. So therefore here it is second priority and this is third priority. The least priority is hydrogen atom, that is 4. Okay. So after the giving priorities, if the least priority group is present at horizontal, so we will interchanging of these groups. If we interchanges, the position of this substance will be changed. Here the position of CH3 is here, so here this is the position of OH and the position of COOH. After the interchanging, give the priority same as it is what you have mentioned in above. So 3, 4. Here we have one direct method. Why we are interchanging? Because if the least priority group is located toward the observer, so here we have to change away from the observer. So due to the reason we are interchanging the least priority group, it will be away from the observer. It comes bottom vertical in bottom. So after the giving priority, we have a direct method, that is by there is no interchanging, means there is no work on paper. So just you can do direct. The method was given by Epling. So here give the priorities like 1, 2, 3, 4. So if the rotation is 1, 2 means it indicates anti-clockwise direction. If it is anti-clockwise direction, then take the reverse of configuration. Means if it is anti-clockwise means S configuration, take it reverse is R configuration. So that is Epling method. It is a direct method. When we applicable for this method, if the hydrogen, if the least priority group is present at horizontal position, if the least priority group is present horizontal position, then we can apply direct method is Epling method. So here 1, 2, 3, 4. So this is R configuration. So this is R configuration. Okay, we will see the second example. You can see already I have mentioned the priorities, you know very well. Here we have carbon atom, hydrogen, oxygen atomic number is more, so that's why first priority. Here we have CH2OH, the carbon atoms are same, so that's why we are moved to second. So that is the second is oxygen atom, that is C double bond O. So that's why this is the second priority and third priority. So after the priority is given, then look at the direction. Here you can see the direction is anti-clockwise direction. So then we will change the interchanging of groups. Here we are changing interchanging of group CH2OH hydrogen. here OH, CHO. So give the priorities same as it is. Here this is 1, 2, 3, 4. After the giving priorities, whether it is checked whether it is clockwise or anti-clockwise. So this is clockwise direction. So that's why it is a R configuration. So you can do the direct method, applying method also, because here you can see it indicates anti-clockwise direction. See, if the least priority group is located horizontal position or toward the observer, so just change it conversion. So write the inverse configuration, that is S configuration is turns into R configuration. That is the direct method. So it is the direct method is very helpful in entrance examination point of view.